Let's imagine that you were snorkeling at a protected wetland known as the Bashkill between Orange County and Sullivan County, New York, and you made the following observations: that here in late July, the aquatic vegetation is certainly growing. It is a hot day, and certainly the water is warm. And this is the type of underwater habitat that you tend to find. There are numbers of aquatic vegetation. There's obviously algae floating in the water, which is blocking visibility. This is obviously food for small minnows, such as dace. But as you get to this one specific region where another stream enters the Bashikil, you notice that the water gets colder because the incoming stream has colder water than the Bashikil that you've been swimming in. It's maybe a foot deeper than it had been. But notice the difference in the vegetation, but then also notice the difference in the fish. Instead of seeing the quantity of minnows that you had seen before, now there is a collection of trout. And trout, which tend to be, shyer fish, that if you were, say, snorkeling in the Delaware and saw a trout, it would swim away rather quickly. These seem to be staying in this area. Why? That's an important question. And when we study the natural world, very often a problem is that unlike a controlled scientific environment, there are more variables than just a single experimental variable. So why are the fish here at this spot, the trout, different from what we were seeing earlier? Why aren't the trout in the majority of the aquatic habitat of the Bashikil? Is it because of the vegetation? Is it because of the colder temperature of the water? Is it because the slightly greater depth? Is it because in late summer there might not be as much oxygen in much of the water because the warmer that water gets, the less oxygen it holds? Might it be this colder water is holding more oxygen, which these larger, more active fish need? What is the answer? How would you design an experiment which then attempts to minimize these variables so that you could isolate them and study them one at a time? Because otherwise, if you compare two spots and they differ by 4 or 5 different variables, then even if you see a difference in fish, you're not quite sure which of the variables was responsible for that difference. How would you design an experiment to attempt to answer this question?